What better way to look at break even than from the shores of Hawaii? Obviously, a good place to target to go. So if you ever get a chance, head out there. So today we're going to talk about break even or cost volume profit analysis. So this is a great way for managers to make good decisions about the company, to plan to decide what to do. And also, this helps us to focus on the fact that in order to make money, we have to have enough sales, enough volume of sales to cover our fixed cost and have some left over for profit. Okay? So the first thing we do to switch to a variable cost income statement is take a little look at our income statement and switch that around a little bit. So we're going to say that sales less variable costs equals contribution margin. And if we subtract fixed costs from that, we'll get our net income. So total cost equals variable cost plus fixed cost, right? Okay. And sometimes we don't have a really good feel for this unless we start tracking things, unless we actually do some analysis. So I'm going to do a short analysis on estimating cost over here, and I won't use all the methods we used before, but we'll use a couple. Okay. So probably the easiest way to do this is to highlight some numbers, and these are different costs and different units from problem 18.7 in the Weil book. Okay. So what I'm going to do is I'm going to click Insert on my Excel tabs, and I'm going to click Scatter Graph. I'm going to click on just the first one here. Okay. And it gives us a little scatter graph of the cost, and these costs are so even. This is totally unlike reality. Normally costs are going up and down and up and down. Okay. So once I do that, I'm going to put the cursor over any point. You can pick a point if you like. I'm going to right click on my mouse and go down to add a trend line. Okay. And then I'm going to just check display the equation on the chart. And here we have a nice relationship. So what this means is our total cost in this case equals 1.5 times the number of units sold, and that function is our total variable cost, plus $2,500. $2,500 represents our fixed cost, so that's one way to do this. Another thing we can do, and this is a much better way to do it, we could also run a regression. I'm not going to show you that today. Another way is we can use a high-low method. So we can look for the highest and the lowest level of units. So our highest level is 3,600, lowest level 0, and the cost that's next to them. So for 3,600, we've got $7,900 of cost. For our 0 level of units, we've got $2,500 worth of cost. Okay. Then we're going to take the difference between those two numbers. So it's 3,600 units and $5,400 in cost. All right. And then we're going to divide. So if we divide our 5,400 in cost divided by 3,600 in units, we get our variable cost per unit, or $1.50. Okay. And since this column represents our total cost, we can go back to either of our 2 points, and in this case it doesn't really matter. I guess we'll pick the highest one to start with. So if we've got 3,600 units, we multiply that times our $1.50 variable cost, we get $5,400. $5,400 is our total variable cost. We subtract that from our total cost, $7,900, and we get our total fixed cost, $2,500. So in both cases, we come out with the equation of why our total cost equals $1.50 times the number of units sold, and that function is our total variable cost, plus $2,500, and that's our total fixed cost. Okay? So variable cost is the only cost that changes when we change the number of units. The fixed cost stays the same. All right. And let's go and look at what else we can do in this particular idea. And we've got a few other things we can do. Here's some formulas that I put together. These are all break-even formulas. And again, our income equals revenue minus fixed costs minus variable costs. Contribution margin, which is revenue less variable cost. Contribution margin per unit, again, price or sales less variable cost. Contribution margin ratio is our contribution margin divided by our sales or price. And if we want to figure out how many units we need to break even, take our total fixed costs divided by contribution margin per unit. Total break-even sales volume, total fixed costs divided by contribution margin ratio. Target units, let's say we want to make $1 million. We figure that out by taking our fixed cost, adding it to our target profit, $1 million, divided by our contribution margin per unit. That'll give us the number of units we need to sell to make $1 million. All right, which is something I hope you're all shooting for. All right, here's the demonstration problem. This is on page 795. And this says Sports Cap sells caps. So they have a fixed cost of $150,000, sales price of $8, variable cost of $5, contribution margin of $3. So I calculated the percentages of sales on each of these. Sales is always 100% of sales. Variable cost, 5 divided by 8, 62%. Contribution margin, 3 divided by 8, 37%. So that's kind of where we're starting. Okay. It says contribution margin per cap. I figured that out. It's $8 less $5. Break even point in terms of number of caps produced and sold. So break even is going to be equal to our fixed cost divided by contribution margin per unit. That gives us 50,000 units. If we sell 50,000 caps, we're going to break even. Break even means we have zero income. I'll just run that over here. See, if we sell 50,000 at $8, it's 400,000. Our variable cost would be 50,000 times $5. It's 250,000. So our contribution margin would be 400 less 250, 150,000, and subtract our fixed cost. We're at break even. Break even is zero profit. If we sell one more, we're making money. One less, we're losing money. Okay. So in units, that's what it is. Break even in dollars of sales. Here we go and take our fixed cost divided by contribution margin percent, 0.375. Looks like $400,000 worth of sales, which is what we came up with over here, and we're going to be breaking even. What else do they have? Let's switch it around a little bit. Let's say we want to make, let's go for $1 million. We want to make $1 million. A likely figure, right? So if we take a look at our formula, that's going to be fixed cost plus target income divided by contribution margin per unit. So this would be the number of units we have to sell. If I divided it by the percent, it would be the dollars worth of sales. It looks like we're going to have to sell 383,333 units to make $1 million. So the only thing I can say to that is we need to get busy.